A bullet of mass 10 grams traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. We have to calculate the distance of penetration of the bullet into the wooden block and the force exerted by the block on the bullet. So first let's calculate the distance of penetration of the bullet into the block. That is the distance the bullet has travelled after it has entered the block. So let's write the given information first. Given mass of the bullet is 10 grams is equal to, let's convert this into kg. This will be 0.01 kg. Then initial velocity of the bullet is U is 150 meter per second. Final velocity of the bullet is 0. Since it comes to rest, the bullet V is 0 since it comes to rest after it strikes the block. Now let's calculate the distance of penetration of the bullet into the block. For that we need to first calculate acceleration of the bullet. So for acceleration the formula is V minus U by T. Since time taken by the bullet to come to rest is 0.03 seconds, acceleration will be A is equal to V is 0, U is minus 150 and T is 0.03 seconds. This value is minus 5000 meter per second square. Acceleration is minus 5000 meter per second square. Since we now have acceleration, let's calculate the distance of penetration of the bullet using third equation of motion. Since V is 0, 0 square minus U is 150 whole square is equal to 2 into acceleration is minus 5000 and distance of penetration is what we need to calculate. So this will be 150 whole square will be 22,500 and 2 into minus 5000 will be minus 10,000 into S. So the distance will be 2.25 meters. Distance of penetration of the bullet will be 2.25 meters. So we have calculated first part of the question. Second part is calculate force exerted by the bullet on the block. We have to calculate the magnitude of force exerted by the bullet on the block. From Newton's second law, we have F is equal to ma. So mass of the bullet is 0.01 kg into acceleration is minus 5000 meters per second square kg. So force will be 0.01 into minus 5000 is minus 50 Newton. Here the negative sign indicates that the force is a reaction force. That is the force exerted by the wooden block back on the bullet. Hence the negative sign. And here as well the minus sign indicates that the bullet is accelerating. So the distance of penetration of the bullet is 2.25 meters and the force exerted by the block on the bullet is minus 50 Newton. Next, an object of mass 1 kg travelling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. We have to calculate the total momentum just before the impact and just after the impact. That is total momentum before and after collision, and we have to also calculate the velocity of the combined object because after collision the two objects move in a straight line. So let's first write the given information. Given that mass of the object is 1 kg. Its velocity is 10 meter per second before collision. And then mass of the wooden block is 5 kg. Before collision, it is at rest. Its initial velocity will be 0 meter per second. Now we have to calculate the total momentum before and after the impact. So first, after collision, they travel in a straight line. So we can write, because they travel in a straight line, we can write, let the velocity of the combined object be V. And total mass of the system, total mass will be m1 plus m2 after collision. So from law of conservation of momentum, we have total momentum before collision is equal to total momentum after collision. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 mass of the object is 1 and u1 is 10 plus mass of the block is 5. Since it is at rest, its velocity would be 0. And same thing, mass of the object is 1. Since we have chosen velocity to be v, it will be m1 m2 into v. This is velocity of the combined object. Now this is 10 is equal to 1 plus mass of the object is 1 and mass of the block is 5. So it will be 1 plus 5 into v. This will be v is equal to 5 by 3 meter per second. So the velocity of the combined object is 5 by 3 meter per second. Now we have to calculate the total momentum just before the impact and the total momentum just after the impact. So the total momentum just before the impact is m1 u1 plus m2 u2. That is total momentum before collision. Total momentum just before the impact is m1 u1 plus m2 u2. Now this is nothing but we have already calculated 10 kg meters per second. Now total momentum just after the impact would be m1 plus m2 into v. Velocity of the combined object is 5 by 3. So this will be 1 plus 5 into 5 by 3. 6 into 5 by 3, which is also 10 kg meter per second. Hence, total momentum just before the impact and total momentum just after the impact are same, 10 kg meter per second. So that's it for today's class. Please practice the numericals without seeing in your journal. Thank you.